Alright, today we're going to talk about two theorems. We're going to talk about the perpendicular bisector theorem, and we're going to talk about the angle bisector theorem. Let's start off with the perpendicular bisector theorem first, and let's talk about these two words. Perpendicular bisector. Does everybody remember what perpendicular means?
Yes, everything go like across, right?
Okay,
Across.
it's two lines that intersect.
Yes.
Okay, and what happens when they intersect? They form what? They form angles, but they're two special kind of angles. What kind of angles are they?
Alright.
They're right angles. Okay, so a perpendicular means two lines intersect and form 90-degree angles. Okay, next word is bisect. When I bisect something, what I do?
This, spread it apart.
No, I don't spread it apart. I do what to? I cut it in half. When you cut something in half, what happens when you cut something in half? You have two parts that are what?
Equal.
Equal. Okay? So what this is basically saying is this. We got two lines that are going to cross and form 90-degree angles, and they're going to cut each other in half and form two equal parts. Okay? The perpendicular bisector theorem says this, word for word. I'm not going to have you write it down because we're going to draw a picture because a picture makes more sense. Perpendicular bisector theorem says this. If a point is on the perpendicular bisector of a segment, then it is equidistant or the same distance from the endpoints of the segment. Okay, what that basically says is this. I have this segment out here in space. We'll call this segment AC. And then I have this other line that drops down and forms 90-degree angle. That's the perpendicular part. Okay? And it cuts segment AC in half. So when I cut AC in half, we'll say that's point D, I now have this happen. That is equal to that. Okay? So if this is 4, what's this?
4.
That's 4. If this is 10, what is this? 10. If this is 10, what's the whole segment equal to? 20. Okay? How's it equal to 20? Well, if this is 10, this is 10, and 10 and 10 make 20. Okay? The other part of this says this. Pick any line, any point you want to on this perpendicular bisector. So I'm going to pick this point right here. Okay? And we'll call that point B. From that point to the end point of this segment, from that point to this point, and from that point to this point, now this is equal to this. So two things happen in the perpendicular bisector. Your bases here are equal because they're cut in half, and then the sides are equal also. So if this is 10, what's this side equal to? 10. If this is 4, what's this equal to? 4. Okay? Does that make sense? That's pretty simple, isn't it? I can pick any point I want to. I pick this point right here. From this point to this point, and from this point to this point. Those two are going to be equal. Okay? All right, let's look at some examples. We'll do an easy one first. Here we go. Let's draw a triangle here. I'm going to draw it upside down. I'm going to draw a perpendicular bisector from the bottom upward. Okay? And I'm going to say that this side is 2.5, and this side is 4, and this is A, B, and C. Now I want you to find what AB is equal to. Okay? What's AB, the segment AB, equal to? Well, here's what I have to do. I have to know something. That bisected that AB. So I know that's 2.5. So what's that going to be equal to? 2.5. Now my question was, find AB. Well, 2.5 plus 2.5 makes how many? If I add this and this, it makes 5. So AB is equal to 5. Okay? That's as simple as it gets. All right? Let's look at one more. Let's look at a little more complicated one. Not hard, just more complicated. Got a perpendicular bisector dropped. This side, we'll call this H, we'll call this J, and we'll call this K. HJ is 3x plus 1. HK is 5x minus 3. I want to find what HK is equal to.
Was it AK?
HK.
Wait,
HK is right here. Well, coach, it's equal to 5x minus 3. Yeah, I understand that, but that's not what I'm looking for. I'm looking for what is the measure.
2.
Okay? Now hang on, before you just start blurting numbers out there. You need to understand this. What is that and that?
An X point.
They're X's, yes, but what do you know about that side and that side?
They different.
They're equal.
No way.
Yes, they are equal. So to find what X is, I got to set them equal to each other. Because remember, that's equal to that.
A triangle.
Okay, yeah. So I'm gonna go 3x plus 1 is equal to 5x minus 3.
Okay.
Okay? Now I gotta solve that for x.
Yeah, you get the X's.
Alright, here we go. Subtract 3x
On both sides.
on both sides. That's gone. Bring my 1 down, bring my equal down. 5x minus 3x is 2x minus 3.
Then you want to plus 3.
Then I wanna add 3.
That's 4.
That's gone. Bring my 2x down, bring my equal to 1 plus 3 makes 4.
Divided by 2.
Divide by 2.
It's 2. It's 2.
X equals
Like I
2.
said,
But that's not what I asked. I said, what is HK equal to? So what am I gonna do with that
It's
2?
equals to HJ.
I'm gonna plug it in. If I take that 2 and I plug it in, now it's gonna give me a measurement. Okay, and that's what I'm looking for. So I'm gonna take 5 times 2 minus 3. That's gonna give me 10 minus 3, which is 7. So this side right here is 7. What's that side gonna be equal to? 7. Okay, so sometimes you might have to solve for x and take x and plug it in. Okay? Does everybody understand that?
Oh, so you just put the 2, you replace the S with the 2, right?
Yes, you replace the x with the 2, yes. And I bet if you took 2 and plugged it in here, you get 7 also. And 3 times 2 is 6 plus 1 is 7. Okay, does that make sense? But what you have to remember is this. That side in a perpendicular bisector, that side and that side are equal. And that are equal. Okay? Alright, moving on. Let's talk about angle bisector. Alright, we've already discussed what a bisector is, right? It cuts something in half. So what's an angle bisector gonna do? Cut an angle in half. Alright, so here we have angle ABC. And I'm gonna draw an angle bisector, and we'll label that D. Now, BD has cut ABC in half, and this is what happens when you do that. This angle is now equal to this angle. Okay? Everybody got that? So ABD, so if this is 30 degrees, what's this one gonna be? 30 degrees. Okay? Alright? Now the angle bisector theorem says this. Word for word. It says this. If a point is on the bisector of an angle, then it is equidistant or the same distance from the sides of the angle. Alright, so I can pick any point I want to on this angle bisector. Let's pick this point right here. It says that from that point to the side, is equal. So if I drop a line down and I make that 90 degrees, and I drop a line down and I make that 90 degrees, guess what? That is now equal to that. So not only are the angles equal, but the point on the bisector to the side of the angle is equal also. So if this is 4.5, what's that going to be equal to? 4.5. Okay? Does that make sense? Yes? Would you like to look at one? Sure, Coach. I'd love to. All right, fantastic.
When you're done,
Like explaining this stuff now to the rest of them?
Don't I always let you?
Yeah.
Okay. This is 23. What's that segment gonna be equal to?
It says 3.
23. Okay, is that angle equal to that angle?
Yes.
Yes. Okay, you see how hard that is? Is that hard?
No.
Let's do one more. There we go. Got an angle bisector right here. That's 2x plus 5, and that is 4x minus 25. Let's find x. Okay, now what do you know? Well, I know that's an angle bisector, so it cut this big angle in half, so I know that is what to that?
Equal.
Equal. Okay, so here we go. 2x plus 5 is equal to 4x minus 25. Most of the time, that's what you're doing today when you're given an x. You're setting them equal and finding an x. That's what you're doing today, okay? So we gotta move the x's. 2x, 2x. That's gone, left with 5 equals 2x minus 25.
Plus 25.
Plus 25. That's gone, bring my 2x down, equals 30.
Divide by 2.
Divide by 2. Gives me x equals 15.
And then you're gonna,
Don't have to plug it in because I just asked for x.
15.
But if I wanted to find out what this angle is equal to right here, what would I do with that
Plug it
15?
in.
I'd plug it in. So let's take 15, let's plug it in. 2 times 15 plus 5. 2 times 15 is 30, plus 5 is 35. So this angle is equal to 35 degrees. What's this angle equal to? 35 degrees. Okay, now is that hard?
Oh, this is easy.
That's pretty simple, isn't it? Okay, pretty simple.